hand of a watch. So the idea of an absolute simultaneity is central to keeping time. And with this simple thought experiment, we see that simultaneity is not absolute. It changes given the reference frame of the observer, which is not such a bad thing. Time is not exactly a law of the universe, neither is distance. So Einstein saw that this paradox of the Michelson-Morley experiment, the idea that the velocity of light was not affected by the motion of the Earth, it's not so paradoxical when you drop your conception of an absolute time. That the contradictory ideas of the relativity of the laws of nature and the constancy of the velocity of light are no longer at odds with each other if you let go of another so-called absolute, that being time. If you relinquish the idea that time is some sort of absolute reference frame, then you're able to maintain the law of the speed of light and the laws of electromagnetism given uniform motion or a stationary observer. So instead of the velocity of light changing, it's your time that changes in reference to the velocity of light. And we can go back to our friend the police officer who's chasing after the speed of light. So same two police officers. One on the left is going to stay stationary. They're each equipped with identical clocks and speedometers, or speeding guns. The stationary cop is going to observe the speed of the running cop, and the running cop is going to observe the speed of the ray of light. The faster and faster this running cop goes, the velocity of light is not changing. So how is this possible? What is changing so that the law of the constancy of the speed of light is maintained? So, take a closer look. What's not changing? Well, the speed of light is not changing. And the stopwatch looks like it hasn't changed much. So in order for the moving reference frame to maintain the constancy of the velocity of light, his time changed. Amongst other things. So that the time for the speeding police officer is actually different from his stationary friend back on Earth. If they were to return and compare notes to write a report on this speeding ray of light, they would disagree with the occurrence, the times at which these events occurred. Yeah. The two eyewitnesses would disagree heavily. For one officer, the whole event took 15 minutes. For another, maybe about a minute. So in order for the laws of nature to be maintained, given the relative motion of the observers, you have to throw out your notion of a fixed time and also a fixed distance as a consequence of that. Which for a lot of people that they were very upset over this. But for Einstein, it made perfect sense. Why would something like a measurement on a clock be more primary than the experimentally proven constancy of the speed of light? The speed of light was something fundamental, in his view, was something fundamental to electromagnetism, to science. So why would that take a secondary place to a stopwatch? He said, then look at the world with the question of the velocity of light. What is the world going to look like if we maintain the velocity of light as an invariant? How is the rest of the world going to shape itself around that principle? And that's when he was able to drop the conception of fixed time. At least, yeah, that far he was able to get. But we more and more have to get to that in a perpetual way. Always thinking about how the universe has to shape itself to principles. Because when we think of the world, we sometimes think of a box with objects in it. But it's actually inside out, that the universe is the principles which are containing the objects. And you use containing in a different sense now. It's not like a Tupperware container. But it's that these principles are bounding the objects which we interact with in a tangible sense. So that if you really want to interact with these tangible objects, you're going to act on that which is containing them, these principles, these processes. And you're going to start viewing the universe as inside out, in a sense, shaped by these principles. But when we say invariant, like when we're looking at the invariant velocity of light, we think of some fixed velocity. But that's not actually what the term invariant means. It doesn't mean, okay, we're dropping our idea of a fixed time and now making light fixed. You have to drop entirely your idea of what you think fixed means. That the principles that we say are invariant, that can be discovered no matter your perspective, whether you're stationary or in uniform motion, they're not something that's fixed. They're not something that you can constrain to a linear process. And then again, it's not something that you can say simply that they change, that they change in a regular, knowable way. It's the fact that they are a process which creates change that makes them invariant. And so it's not a fixed object in the way we used to think about time, but it's a process that generates these shadows. So the special theory of relativity says that all the laws of nature are going to be maintained, whether you're stationary or in uniform motion, not simply the laws of mechanics. So any experiment you conduct, given electromagnetism, optics, mechanics, you're not going to be able to detect whether or not you're stationary observing these phenomena or in uniform motion. So as we saw Leona earlier on the moving walkway, if she was to conduct more experiments, not just looking at Newton's cradle, but also then again looking at the solenoid and different experiments in optics, she would not be able to detect whether or not she was stationary or in uniform motion. She would be able to still argue that, no, I'm stationary. Everybody else, including this whole building, is that which is moving in a uniform manner in the direction of my left. And I can prove it to you because, look, this experiment it indicates that it's being viewed from a stationary viewpoint. So, in the theory of special relativity, all the laws of nature are going to be equally observable from any reference frame. That there's no ultimate box from which you have to view the principles of nature. That they equally reveal themselves to anybody, whether they're stationary or in uniform motion. The only pitfall for some people is that your concept of an absolute time existing outside the universe, which is ticking by itself and can be used as a fixed measurement, that's what's actually changing, given your motion. So you get a sense of what Lynn's brought up before of a type B identity, where the things that are most tangible, that seem most commonplace, most everyday, and almost absolute, almost unchanging, when viewed from